So in this recording I will talk about the probability theorems. The first one is that the probability of any event is between 0 and 1. So 0 means that it will not happen, and then 1 means that it will happen. It will, let's say, so you will have a axis like 0 to 1, and then you have 50% here. So in between, if it is 50%, it is like, maybe happen, maybe it will not happen. More than 50%, you say that it is high likely that it will happen, or low unlikely that it will happen. It's in this range. So you just use the correct word for the other values. But for 0, it will not happen. For 1, it will happen. And the second says that the sum of the probabilities is equal to 1. So let me just show you one example from our, so if you remember this one, we had this 20 steel rods from A and 30 from B and the 40 from C. See, if I add them up, so I have 20 plus 30 and plus 40, 20 by 90 and 30 by 90 and 40 by 90. So from company A, the possibility is 2 by 9. From company B, it is 3 by 9. And from company C, it is 4 by 9. If you add them up, it will be 1. So that is what it says. The possibility of separate events of the same problem is equal to 1. And the third one says that the possibility that event A will not happen is equal to 1 minus possibility that A will happen. This is also a very easy theorem. So it will happen, for example, 30% it will happen. It will not happen is that 70%. It's very simple theorem. And then we have the additive rules, and then we have the multiplication rule. The additive rule theorem is 4 and 5, and then multiplication is for 6 and 7. 4 is for mutually exclusive process, and 5 is for not mutually exclusive process, and 6 is for independent events, and 7 is for dependent events. Let's start from the 4. If we have two mutually exclusive problem, the possibility that A or B will happen is the sum of them. If you remember mutually exclusive problem, it was like if one happens, the other cannot happen, sorry. This is the theorem 4. Let me give you one example. Okay, say that this is the intersection of the road, and then you are here. Then you can go forward, you can turn right, you can turn left, and then you can go backward. So you have 4 options. And I'm telling you, what's the possibility that you can turn left? It is 1 by 4. What's the possibility that you can turn right? It is again 1 by 4. But what is the possibility that you can turn left or right? So you cannot turn left and right at the same time. This is a mutually exclusive problem. If you turn left, then right is impossible. If you turn right, the left is impossible. Okay, you have to choose one of them. But if I ask you, what is the possibility that you will turn left or you will turn right? So that will be 1 by 4, and then plus 1 by 4, it will be 50%. 50% chance that you can take the left or right. Another example here says that you are a manager and you are buying 20 rods from A, 30 from B, and then 40 from C. What is the chance that any selected rod is from company A or B? So we will approach this problem as a mutually exclusive problem, that it cannot happen at the same time that it is from A and B. It is from either company A or company B. So you don't buy them at the same time. So let me say here, it cannot be from A and B at the same time. It is either from company A or company B. So if you remember the formula, it says that the A or B, it will be equal to probability of A and plus probability of the B. So the A is 20 by 90 and B is 30 by 90. It is 50 by 90. This is just the simple addition rule. You add the probabilities. Okay. For example, it will either rain or it will be sunny. It is not possible that it will rain and be sunny at the same time. Okay. So you just add the possibilities. Either rain or sunny. For example, 30%, 40%, add them up 70%. That's all. And then another theorem says that for not mutually exclusive process, the processes that they don't prevent each other, A or B is A plus B minus the both. Okay, let's see the example here. Say that, okay, say that 7 people knows Spanish. Okay, 8 knows French, and then 3 knows both. Okay, 7 Spanish, 8 French, and then 3 both. Okay, so this one is a not mutually exclusive process because, as you can see, let me say Spanish only and French only. It is possible that the people can know Spanish and French at the same time. It is not mutually exclusive process. It doesn't mean that if you know Spanish, you cannot know French. It is possible you can know Spanish and French at the same time. And then, if I ask you what is the number of people that knows Spanish, it is 7 plus 3, which is 10. Because 3 also knows Spanish. Okay, but Spanish only is 7. Also, they knows French, that is 11. Because 8 knows French and 3 knows both, so 11% knows French as well. So this is mutually exclusive, not mutually exclusive process. Okay, how it looks like. Now let's solve a problem. Say that we have 29 parts and then 29 parts that need heat treatment. 12 parts need plating and 9 parts need both plating and heat treatment. It is like the language problem. Some knows English, some knows, for example, Spanish, French, and both knows French and Spanish, whatever. So 29 parts need heat treatment and 9 needs both. So 9 is here, it needs both heat treatment and the plating. 20 needs only heat treatment. Okay, 9 needs both. So it means that 9 plus 20, 29 needs heat treatment. And then 3 needs only plating. As you can notice, 12 needs both and 3 needs only plating. If I ask you, what is the possibility that it needs plating? It is 3 plus 9, which is 12, by the number of them. How many of them are there? 3 plus 9 plus 12. It is a 32. So you have to be careful here. So number of products is not equal to 29 plus 12. You have to be careful here because you will count 9 twice in that case. Number of products is 20 plus 9 and plus 3, which is 32. And then possibility that they need plating is 12 by 32. Possibility that they need only plating, that is 3 by 32. Similarly, possibility that they need the heat treatment is 29 by 32. Possibility that they need only heat treatment, it is 20 by 32. Okay, anyway, you can go this way and then find it, but we have to go back to our theorem. It says that possibility that it needs either plating or heat treatment, that will be equal to possibility that it needs plating plus possibility that it needs heat treatment and minus possibility that both. What is the possibility that it needs plating? It is 12 by 32. Again, be careful, it's not only plating, it just needs plating, yes? 12 by 32. What's the possibility that it needs heat treatment is 29 by 32. Okay, now you can notice I counted 9 twice. As you can notice, when I say 12 by 32, I counted 3 by 9 twice. When I said 29, I counted 20 and 9 twice. No, sorry, 9 again. So the formula was saying that subtract the both. So because since I counted twice, if I subtract it, I will get the correct result. Okay, that's the logic behind the formula. And then 32 by 32, and which makes 1. You see, which is okay because now I counted all the possibilities, which is it needs either plating or heat treatment, includes all the possibilities. Okay, that is the reason that we get the result as 1. These are the theorems for addition and the simple introductory theorems. In the next recording, I will talk about the theorems for independent events.